Okay, which is a valid conclusion to be drawn from these statements? If a quadrilateral is a rhombus, then it is a parallelogram. Okay, so that we could call, if a quadrilateral is that is a conditional statement. That's like a if P then Q, which we saw in the first problem. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so what does it look like they're trying to do here? You know, it would appear they're trying to link the end of that one to the beginning of that one, which we have a property, trying to think. I think in geometry, this is the one they call the law of syllogism. And I am looking in my book right here. The law of syllogism. If P, here we go. Right? If P implies, if P then Q, if Q then R, then if P then R. Meaning, if you could tie the end of this statement to the beginning of that statement, then you could just make it an if P then R. That is exactly what we've got in this problem here. I can call this first one, I'm going to say that is that is P implies Q, right? If the quadrilateral is rhombus, then the quadrilateral is a parallelogram. If the quadrilateral is a parallelogram, then its opposite angles are congruent. So what should we be able to say? We should be able to say that if this, then that. That's the law of syllogism. So which one of these says if a quadrilateral is a rhombus, then its opposite angles are congruent? So let's see. If every quadrilateral is a rhombus? No. Every parallelogram is a rhombus? No. Opposite angles of a rhombus are congruent. And even though it's not stated in that way, right, if the quadrilateral is a rhombus, then its opposite angles are congruent. That is what we're saying. Opposite angles of a rhombus are congruent. If it is a rhombus, then the opposite angles are congruent. See? That's a law of syllogism.